Welcome the third presenter, Joseph, please.
Okay, my name is Joseph. So today I want to talk about Flywheel Energy Storage System, FESS. So to start with, here I have mentioned Taiwan's 2050 net zero target. And right now we are in 2025 and Taiwan's 2050 goal is to reduce the greenhouse gas emission reduction by zero. So for that, Taiwan have introduced 12 key strategies. And one of the strategy is power systems and energy storage, where our research group is continuously working on. So that is Flywheel Energy Storage System. What is a flywheel energy storage system? I want to introduce a brief introduction about my flywheel energy storage system. It is a mechanical device. It have motors, generators, magnetic bearing flywheel, and vacuum chamber. Let's start with energy storage or charging phase. First, the electrical energy from the grid or renewable source powers a motor, such as the wind power, solar, or electricity grid or hydrogen fuel. It generates the power and transfer it to microgrid manager, and then uh, the the power is stored into any energy storage device. Okay. Okay. The motor spins the flywheel at very high speed up to 12,000 rpm. So here the motor and flywheel is connected in a single shaft, so it rotates together. Then the kinetic energy is stored as rotational energy. Next is energy retention. The flywheel spins in a low friction environment like vacuum and magnetic bearing. So inside the vacuum, we have no other components which will create any friction. So it rotates at very high speed. The minimal energy loss over time, and it can retain energy for several hours, depends on the design. The last one is energy discharge or discharging phase, where when energy is needed, like maybe some power outage, or if there is any earthquake or typhoon, when there is a power needed, the spinning flywheel drives the motor in reverse as a generator. Then the stored kinetic energy is converted back to electricity and fed to the grid or load. I want to compare FESS versus lithium ion battery. First, I want to talk about energy density and power density and the example. Energy density is the amount of energy stored in a given volume or mass of a substance or system. Example, a battery with a high energy density can store more energy for a given size. Even the smaller size battery can store a lot of energy. So that's energy density. And power density, the rate at which energy can be released or delivered from a given volume or mass. Example, a battery with a high power density can deliver energy quickly, making it suitable for applications that require bursts of power. This is very important, like starting an engine or powering tools. Let's come back to the comparison table. FESs have very high power density, but it have medium energy density. Lithium ion, on the other hand, have high energy density, but the power density is medium. The response time is instant because the generator and motor is connected to a single shaft and it can instantly change its operation technique. Okay, lithium ion battery, it takes some seconds to respond. The cycle life is very high, up more than 100,000, and for lithium ion battery, it's 3,000 to 10,000. The maintenance is really very high, like up to 30 years, you don't have to worry about FESS, but after every 3 to 5 years, you must change the lithium ion battery. Okay. Environmental impact, cost over life, and fire risk. Okay. At first, the cost over life cycle for FESS is very high because the installation may seem like it's expensive, but at the long term, like 30 years, it's really very, very low. Okay. For lithium ion battery, as after 3 to 5 years, you must change it. So it needs a very high uh, cost over cost over life cycle, and the fire risk is none. I will explain why. And for lithium ion battery, it's very high. In Taiwan, Ember Kinetics partnered with PTLK International to deliver Taiwan's first 8 kilowatt and 4-hour FESS at 2019. So the design is rugged, so it can be operated through earthquakes and typhoons. The maintenance is low, as I just told you. It can work up to 30 years and it have very high resilience. Okay. Here I have mentioned the key technical characteristics and performance of the FESS. The energy capacity can range from zero point 0.5 to 500 kilowatt hour. The power output can be from 5 kilowatt to 10 megawatt. One flywheel system can generate from 5 to 10 kilowatt power. But if we have grid like this, we can generate very high power such as 10 megawatt. The response time is less than 5 milliseconds. That is why I mentioned it's instant. And the fire risk is low because the materials are steel, carbon fiber, or any composite, so it doesn't catch fire. We at ITRI K300, this is our research group, we have several FESS technology, such as passive magnetic bearing and active magnetic bearing. PMB uses permanent magnets like neodymium to generate the magnetic field and balance the rotor, as I've showed here. On the other hand, AMB uses electromagnets and sensors to actively control the position of the rotors. Okay. In PMB, they do not require any external power to maintain the levitation, but in AMB, sensors continuously monitor the rotor's position and a closed loop feedback control system that adjusts the current and keeps the rotor always in centered position. Okay, this is our flywheel system and our testing apparatus. I have compared our E3 K300 flywheel system with the commercial Ember kinetics. So the design life and temperature is similar, but the power generation, the maximum power is higher than Ember kinetics. We are doing up to 10 kilowatts and Ember have 8 kilowatt power. Okay. And what we can do uh, in terms of support in FESS is in design and engineering, simulation, testing optimization, deployment, and support. These are several things we can help you. So thanks for your time. And if any listeners online would like to cooperate technologically or commercially, you're welcome to contact us. I've mentioned my manager's email ID here, and this is my email ID. Thank you.